Hi everyone, here are your notes for section 9.3, which gets us into equations in quadratic form. So now what's going to be happening is we know all of our methods on how to solve quadratic equations. So now we're going to just kind of up the game on our equations and how they start and how then it will turn into a quadratic equation that we're familiar with. So keep in mind the methods that we have for solving quadratic equations are, we can solve by doing square roots. This is if it's not factorable, right? Square roots, completing the square, we can use the quadratic formula. And if your quadratic is factorable, maybe factoring is favorable for you, then go ahead and factor it. So from this point on, you get to choose whatever method you want to use. I'm not going to say make sure you solve it using this method. You pick the method that you're most comfortable with. So here's our first example. We have a rational equation with 1 over x plus 1 over x minus 1 equals 7 over 12. So remember, we have to find the least common denominator of all those fractions, which is pretty much going to be everything, right? So I need to have a 12 everywhere. So that means I need a 12 in the top and the bottom of my first fraction. I need a 12 in the middle fraction. I have a 12 in the last. I need an x everywhere. Well, I have an x in the first, but I need an x in the middle, and I need an x in the last. And I need an x minus 1 everywhere. So I need that in the first, and I need it in the last. So now all my denominators have a 12, all my denominators have an x, all my denominators have an x minus 1, right? So remember, when all of my denominators are the same, I can just ignore them because they end up canceling them out, and I can just focus on the numerator. So 12 times 1 is 12, so when I distribute that through, I get 12x minus 12. 12 times 1 is 12 times x is 12x is equal to 7 times x is 7x. Distributing there gets me 7x squared minus 7x. So now I have a quadratic equation that we should hopefully be able to solve. Let's see, let's shift everything over to the right side because that's where my quadratic term is. These guys come together to make 24x. So I'm going to subtract a 24x over. And it looks like we're going to add a 12 over. So that gets my quadratic to look like this. 0 is equal to 7x squared minus, what would that be? 24 and 6 would make 30, so 31x plus 12. So we could check to see if it's factorable. 7 times 12 is what? 84. So we try to come up with factors of 84 that get you to 31. I could check my discriminant, right? B squared minus 4ac to see if that's a perfect square. Well, my b is 31, so 31 squared minus 4 times 7 times 12 is 625, which is a perfect square. So this would be factorable. So I could try factoring it. Definitely probably don't want to complete the square on it. Completing the square would be really rough because I would have to divide everything by 7, which is going to get me some funky fractions. And then I would have to take negative 31/7 and divide that by 2. Yep, let's not even go there. Quadratic formula would not be terrible. That might be what your first instinct would be. So we can do it both ways. Since it is factorable, let's see if we can remember how to do that. Factors of 84 that get you to 31. 84 and 2 is 42 and 2, so that's not it. 84 divided by 4. 4 and 21, no. So it looks like it's got to be 3. 3 and 28. That adds up to 31. They both need to be negative. I'm going to put them over 7. I can reduce 28 over 7 and negative 4 over 1. So that factors to 7x minus 3 times 1x minus 4 is equal to 0. So my solutions are 3/7 and positive 4. Keep in mind, remember with rational equations, we can't have 0 in the denominator. None of those would give me 0, right? Because here my 0 would be 0, here my 0 would be 1, which is not 3/7 or 4. If you did solve that same equation using the quadratic formula, you can just watch. You would do 31 plus or minus 31 squared, which is 961, minus 4 times 7 times my c, which my c was what, 12, all over 2 times my a, so 14. So 961 minus 4 times 7 times 12 is 625. 14, which is 25, so 31 plus or minus 25 over 14. 31 minus 25 is 6. 6 over 14 gets you the 3/7. 31 plus 25 gets you the 56, divided by 14 gets you the 4. Right, so I got both answers, both methods. Quadratic formula, you don't really have to think maybe as much, it's just kind of plugging it into the formula. But yeah, but remember that discriminant part. That helps you to check to whether you need to, if you can factor it or not. All right, so let's go ahead and move on to another rational expression. So here in my denominators, I have an x minus 1, a 1, and an x. So I need an x everywhere. So I need it in the first, I need it in the middle. I already have it in the last. I need an x minus 1 everywhere, so I need that in the middle and on the last. And then I think I'm good. So in my numerators, I have a 4x in the first numerator. 9 times x is 9x. Distributing gets you 9x squared minus 9x equals, distributing at -7 gives you -7x plus 7. My quadratic term is 9x squared. It's positive on the left, so let's move everything over and combine like terms. So I have a 9x squared. I'm going to be adding 7x. So negative 9x and 7x is negative 2x. Add it with that 4x, so that gets me positive 2x. And then subtract your 7 over. So again, we could complete the square, but that would get really rough because we'd be dividing everything by 9 and then taking halves and then crazy fractions. Can't use the square root property. We could check to see if it's factorable, or we could just jump right to the quadratic formula. -2 plus or minus -2 plus or minus the radical b squared, which would be 4, minus 4 times a times -7, all over 2 times a. Calculator in hand, I'm going to do 4 minus 4 times 9 times -7, which gets me 256. Ooh, this one was factorable too. Shame on me for not trying. That's okay. Square root of 256 is 16. So now I have -2 plus or minus 16 all over 18. So -2 minus 16 is -18. Divided by 18 gets us -1. -2 plus 16 is 14. 14 over 18, I can take out 2, so what would be that, 7/9. So there are 2 solutions. Do any of those make 0 in my original denominators? No. So I am all done. Okay, we're actually going to skip the word problems. We'll save those all for one day. So now we're going to get into solving radical equations that lead to quadratic equations. So we just did rational equations. Now we're getting into radical equations. So here's our first example. Solve the following equations. We have x is equal to the square root of 6x minus 8. Well, how do we undo a square root? We take the square, which undoes the radical, and then we're just left with the radicand underneath, which is 6x minus 8. What I do to one side, I must do to the next, so that gets me x squared. Shift everything over to the left. X squared minus 6x plus 8 is equal to 0. Is that factorable? 4 and 2, yeah. X minus 4, x minus 2 is equal to 0. Or let's actually complete the square. I mean, you can finish that out if you want to finish it out, but I'm going to do a completing the square just to get it back in our brains. This wouldn't be too terrible. X squared minus 6x, half of 6 is 3. Squaring that gets us 9, so there's my perfect square trinomial. -8 plus 9 is 1. This factors to x minus 3 squared. Square root, x minus 3 equals plus or minus the square root of 1, which is 1. X equals 3 plus or minus 1. 3 minus 1 is 2. 3 plus 1 is 4, which is what you would have gotten if you factored it and did your zero product property. Let's do another one. X plus the square root of x is equal to 6. So here we're going to get the square root all by itself by subtracting over that x. So now we have 6 minus x. Now we're going to square, make sure when we square that side that we actually multiply it out, or FOIL, or use the shortcut. Shortcut, square the 36. Multiplied through 2 times negative x is negative 2x times 6 is negative 12x plus x squared. That's what you would get if you FOILed it, is equal to x. My square root and my square cancel each other out over there. Everything's positive, my quadratic term is positive on the right, so let's leave it there by just subtracting our x over. And I'm going to rewrite it in standard form. So I'm going to put that x squared first. Then I get a minus 13x plus 36. Do we have any factors of 36 that get to negative 13? Yeah, 9 and 4 is 13, right? If I make them both negatives, leading coefficient's 1. So x minus 9, x minus 4 should get us that. So we get x is equal to 9 and 4. Smallest to largest. Make it fancy. None of those are negative. If they were negative, then they wouldn't work, because then I would get an undefined answer in my radicand up there. All right, now let's solve equations that are in quadratic form. So here we have x to the 4th instead of x squared, minus 13x squared plus 36. So we like to do what we call U substitution. U substitution, where I can let my u equal, and it's always going to be whatever that middle term is. I'm going to let u equal x squared. So then I get u squared, because remember, u squared squared is u to the 4th. So this becomes just a u squared, minus 13u plus 36 is equal to 0. Now we just did that same problem. That's factorable, right? That goes to u minus 4, u minus 9 is equal to 0. So that tells me that u is equal to 4, and we can have u is equal to 9. But my original equation had an x in it. So now I'm going to bring that x squared back down, because up here we said u is equal to x squared. So now I get x squared is equal to 4. Using your square root property, wouldn't that get me x is equal to plus or minus 2? Over here I get x squared is equal to 9. Using your square root property gets you x is equal to plus or minus 3. So writing it out smallest to largest, negative 3, negative 2, 2, 3 are my solutions. Okay. So here we have a quadratic, well, an equation that's not quite quadratic. Our degree is 6 for our highest. So let's just shift everything over to the same side. I'm going to move that 5x to the 3rd over. So I get 4x to the 6th minus 5x to the 3rd plus 1 is equal to 0. Now, again, the beauty of these equations is if you let u equal whatever that middle term is, x to the 3rd squared is x to the 6th. So if I let u equal x to the 3rd, then this whole entire thing becomes u squared. So this first term becomes 4u squared. My middle just becomes 5u plus 1 is equal to 0. I think that one's factorable, isn't it? Negative 4, negative 1. You're not making us think too hard here. So then we get u minus 1 times 4u minus 1 is equal to 0. So u has to equal 1, or u has to equal 1/4. So now let's put our x to the 3rd back in. So x to the 3rd is equal to 1. X to the 3rd is equal to 1/4. How do I undo a cube? Well, I take a cube root of both sides. The cube root of 1 is 1. Not plus or minus 1, just 1. The cube root of, cube root of 1/4. That one's not quite as nice, is it? No. So let's think about this. So the cube root of 1 over the cube root of 4. Cube root of 1 is 1, but now I'm left with the cube root of 4. Well, 4 technically is the same as 2 times 2. So I already have 2 2's. To make it a cube root, I need to add a 3rd 2. So that's going to get me a cube root of 2 in my numerator and a 2 in my denominator. So 1 and cube root of 2 divided by 2 would be my 2 solutions for that one. You have to go back, way back, and remember how to rationalize denominators with indexes other than 2, right? So hopefully you haven't forgotten about that. Here's another x to the 4th. So x to the 4th minus 6x squared plus 3 is equal to 0. So I'm going to let u equal x squared. So now I get u squared minus 6u plus 3 is equal to 0. Ooh, that's not factorable. Ooh, let's complete the square. Why not? U squared minus 6u. Half of 6 is 3. Squared is 9. So negative 3 plus 9. So we get u minus 3 squared is equal to 6. So u minus 3 is equal to plus or minus the square root of 6. U is equal to 3 plus or minus the square root of 6. So I get u is equal to 3 minus the square root of 6. But what did we say u was? U was x squared. So x squared is equal to 3 minus the square root of 6. Ooh. And then we get x squared is equal to 3 plus the square root of 6. Ay, ay, ay. So if we square root that, square root that, square root that, square root that, we end up getting x is equal to plus or minus the square root of 3 minus the square root of 6. And x is equal to plus or minus the square root of 3 minus the square root of 6. Now I'm going to take my calculator out. I'm going to make sure that 3 minus the square root of 6 is still positive. It is. So that one's fine, because 3 plus the square root of 6 would definitely be positive. So there are my two solutions. So we have, which one's going to be smallest? The minus first. So negative square root of 3 minus the square root of 6. And then we have a negative square root of 3. Oops, I have minus twice. This should be plus. Plus the square root of 6. And then we have a positive square root of 3 minus the square root of 6. And we have a positive square root of 3 plus a square root of 6. Oh, I like that one. And it's okay to have a radical underneath a radical. That's okay. Don't be afraid of it. Oh, yeah. Now we're getting really into it. Again, use substitution. It makes your life so much easier. Let u, in this case, equal 4x minus 3. I could multiply all that stuff out, combine like terms, and then just do a quadratic equation with that. But let's simplify it. So that becomes 2u squared plus 7u plus 5 is equal to 0. 2 times 5 is 10. Factors of 10 to get to 7. 5 and 2. Put it over 2. Reduce. Can't reduce 5 halves. Can reduce 2 over 2 to 1. So this factors to u plus 1. I don't know why I did that one first. And 2u plus 5 is equal to 0. So that tells me u has to equal negative 1. And 2u plus 5, oh, nope, u has to equal negative 5 halves. What did u equal? 4x minus 3 is equal to negative 1. 4x equals 2. X equals 1 half. Over here, 4x minus 3 equals negative 5 halves, which negative 5 halves is what? Negative 2.5. So when I add 3 to negative 2.5, I get a half. When I divide by 4, I'm going to get an eighth. So my two solutions are 1/8 and 1/2. So new substitution makes life a little bit easier. I think, oops, we got one more. Again, let u equal your middle term. Whenever you got all this funky stuff happening, that's not just a square root or a rational or quadratic. So if I let u equal x to the 1/3, this becomes 2u squared. My middle becomes 11u plus 12 is equal to 0. Is that factorable? Factors of 24, that get you at 11. 8 and 3 both need to be negative. Put them over 2, negative 4 over 1. So that goes to u minus 4, and 2u minus 3 is equal to 0. So u equals 4, and u equals 3 halves. Plug it back in. X to the 1/3 is equal to 4. Well, how do we get rid of that 1/3? That's the same thing as a cube root of x, right? So I can just cube this, because that becomes a 1. So we get x is equal to 4 to the 3rd, 64. Saying it as I typed it in. Over here, x to the 1/3 is equal to 3/2. Take it to the third power. 3 to the third is 27. 2 to the third is 8. So there are my two solutions. So 27/8 and 64. Okay, getting a little bit complicated, aren't we? Yes, we are, but it's good for you. Embrace it. That concludes your notes.